Okay, now instead of just simplifying things with roots in them, we are actually going to move into solving equations that have different kinds of roots in them, or radicals is another word for roots. So we got 3 steps here. Step number 1 says make sure you isolate the radical on one side of the equation. Step 2 says you're going to then raise each side of the equation to the power that the root is to eliminate the radical. And then we're going to solve and check our answers. So on example number 1a, okay, first thing I want to do is I want to get the square root by itself. So you always want to, just like when you're solving a regular equation, add or subtract the number at the end over first. So 2 times the square root of x plus 5 equals 4. Then you're going to want to get rid of the coefficient, and the coefficient in front of the root, you will divide that away. So then you got the square root of x plus 5 equals 2. Then to get rid of a square root, you're going to raise both sides to the power of 2, because remember, square root, the little index number is 2. Power of 2 and the square root cancel out, so you get just x plus 5 equals 2 squared, which 2 squared is 4. So now just move your 5 over, and you get x equals -1. Okay, so now you got to go through and check your answer. So if I'm checking my answer, I'm just going to go put -1 back into the original problem. So 2 square root of -1 plus 5 minus 1 equals 3. Let's find out if it's true. -1 plus 5 is 4. The square root of 4 is 2. 2 times the outside 2 is 4. And 4 minus 1 is 3. It sure does. So -1 is my answer. Next one. I don't have anything on the same side with the cube root. There's no plus or minus number behind it and no number in front of it. So let's just start by cubing both sides. So then I get x minus 1 equals 2 to the third power is 8. Then move that over and x equals 9. So then go through and check it. So the cube root of 9 minus 1, which is 8, and the cube root of 8 is indeed 2. So yes, it does check. Okay, C. When you look at C, you're going to notice, oh, well, there's a fourth root on both sides, but there's no plus or minus number that's not underneath the root. So hey, we're in good luck here. So I would just say, let's start by taking both sides and raise it to the fourth power, which just gets rid of my roots. So I just have 6x minus 4 equals 2x plus 10. So then I'm going to subtract my 2x over, and I'm going to add my 4 over, which will give me 4x equals 14. And if I divide, x equals 7 over 2, or 3.5. Okay, if I was to check this, so I got fourth root of 6 times 7 over 2 minus 4. Well, 6 times 7 over 2, that would be 6 times 7 is 42. 42 divided by 2 is 21. So I'm looking at 21 minus 4, which would be the fourth root of 17. So now let's check the other side, see if it works out. Fourth root of 2 times 7 over 2 plus 10. Well, 2 times 7 is 14. 14 over 2 is 4. No, 7. Sorry. 7. And 7 plus 10 does give me the fourth root of 17. They are equal, so check. Yay! Okay, next row. On this one, I only have a square root on one side and the square root's all by itself. So to get rid of a square root, I'm going to start by squaring both sides. Boom, boom. Okay, x minus 8 quantity squared. That actually means that I have two of the same parentheses. So remember that little exponent there means two identical parentheses. And then over here, these would cancel out and I get x minus 6. So then you need a box or foil. Okay, so box or foil, whichever one you want to do. So I'm going to make a little box up here. I got x minus 8, x minus 8. So x squared minus 8x minus 8x plus 64. So you're looking at x squared minus 16x plus 64 equals x minus 6. Now you notice you have a squared, so you got to move everything to the same side where your squared is so that you can factor it. So I'm going to subtract my x, and then I'm going to add my 6. So you're looking at x squared minus 17x plus 70. Now I got to factor. Woo, fast factoring. What multiplies for 70 that adds for negative 17? And that would be x minus 10 and x minus 7. So solve them. Pretend like you set them equal to 0. So I get x equals 10 and x equals 7. So now we do have to go through and check them. Okay, if I start with 10, okay, I got 10 minus 8, which is 2. And on the other side, I would have the square root of 10 minus 6, which would be square root of 4, which square root of 4 is 2. Those are equal, so 10 checks out. Okay, next one. Plug in 7. 7 minus 8 is negative 1. Square root of 7 minus 6 is positive 1, and the square root of 1 is 1. But negative 1 is not the same thing as positive 1, so this one fails. Please do not circle it. It does not count as the answer. The only one that is an answer is 10. Okay, next problem. This one, we're getting a little more complicated. The last E and F are the same type of problems. And what makes these a little more complicated is, you notice on E, I have that plus 1 that is not under the root. Okay, so that will make it a little harder. So once again, to get rid of a square root, I'm going to start by squaring both sides. Now, the right side is the easy side because you should notice that everything is under the root there. So that one's easy. So that one just kind of cancels out and gives me 3 minus x. The one that's hard is the front one. And the reason that's hard is because you've got to make a box. Okay, because remember, just like we did on D, that means two of the same thing. So box or foil, whichever one you like better. Okay, so I'm going to come down here. I'm going to make my box toward the bottom. So square root of x plus 2 and then 1. Square root of x plus 2 and then 1. Now remember, when you take a square root times a square root and you have the same thing underneath, they just cancel. So you get x plus 2. 1 times the square root just means I have one of those square roots. 1 times the square root just means I have one of those square roots. And 1 times 1 is 1. Okay, so I got x right here. And then I have a 2 and a 1, so I can add those together and get plus 3. And then my roots are identical, so I can combine those. Outside numbers, 1 plus 1 is 2 square root of x plus 2. Now, our job is to get the square root all by itself. So I want to get rid of this x. I want to get rid of this minus 3. Now, don't try to subtract that 2, because remember that 2 is in front of the root. So it is actually being multiplied by the root. So don't do anything with that yet. So here I got 2 square root of x plus 2 equals, over here, 3's cancel out. Boom. And I get negative 2x. Okay, to get rid of the 2 in front of the square root, I will divide it away. So square root of x plus 2 equals negative x. And then finally, since I've got the square root all by itself, I can say, oh, let's get rid of the square root by squaring both sides. So the left side, they all cancel out, which is x plus 2. On the right side, negative x squared becomes a positive x squared. Then I have to move everything to the same side so I can factor it. So x squared minus x minus 2. What multiplies for negative 2 that adds for negative 1? So x minus 2 and x plus 1. Solve and you get x equals 2 and x equals negative 1. So if you go through and check, you're going to find out that, one of them fails. Okay, so let's just talk about the one that fails, and the one that fails is 2. So here we go. If I plug in 2, 2 plus 2 is the square root of 4. And the square root of 4 is really 2. And 2 plus 1 makes that side 3. And then if I come over here and plug in 2, well, 3 minus 2 is 1. And the square root of 1 is 1. And 3 does not equal 1. So that one fails. And the other one does check out. So if you take time to go through and check, negative 1 should work. All right, well, let's practice this one more time. Same type. Here we go. Square both sides. Oh, whoops, sorry. Let me get my parentheses in the right location there. So square both sides. Pen, hello. There we go. Okay, this time the left side is easy because everything's under the root. So that means it's just x minus 4. Okay, we're going to make a box for the other one. So I'm going to put my box over here on the side. So I got 7 and a negative square root of x plus 3. 7 and a negative square root of x plus 3. 7 times 7 is 49. 7 times a negative square root means negative 7 of those square roots. And then 7 times a negative square root means negative 7 of those square roots again. And then negative square root times negative square root, well, 2 negatives make a positive. And then the square roots, since they're identical, they undo each other. So you get x plus 3. So we're looking at x minus 4 equals 49 plus 3 is 52. And then we still have plus x. And then negative 7 roots plus negative 7 roots is negative 14 of those roots. So now our job is to get the root by itself. So I'm going to subtract x, which cancels out on both sides. Yay. I'm going to subtract 52. So negative 56 equals negative 14 square root of x plus 3. Ooh, I get to get rid of my negative 14 by dividing it away. So then I get 4 equals the square root of x plus 3. Get rid of a square root by squaring both sides. So 16 equals x plus 3. Subtract that over and x equals 13. If you check it out, it does work. All right, the other type of problems that we have for solving is ones that don't have a square root in them. Instead, they have powers, and the powers can either be a fraction or they could be a whole number. So let's start with the whole number ones. Okay, our job is to get x to the 5th by itself. So let's divide by 4. So x to the 5th equals 32. Now, to get from x to the 5th down to just x, you have to do the opposite of a 5th power, which is a 5th root. So x equals, and then I would take my calculator out and I would type in 5 x root of 32, and that would give me 2. And then remember, because 5th root, because that's odd, you do not need plus or minus. You only need plus or minus when we're talking about an even root. So answer is 2. Done. Next one. Oh, got to get the parentheses by itself. So let's get rid of the 6 first. So x minus 3 raised to the 4th power equals 21. Opposite of the 4th power is the 4th root on both sides. So x minus 3 equals, 4th root. That's an even root. So if it's an even root, I have to put plus or minus. And then if I do 4x root of 21, I'm going to get a decimal. That's okay. Let's just round the decimal off to the hundredths. So 2.14. So now I'm going to move my 3 over. So x equals positive 3 plus or minus 2.14. Now I'm going to split my plus or minus. So 3 plus 2.14 and 3 minus 2.14. So I have 2 answers, and they are 5.14 and 0.86. All right, now let's get into the ones that have fraction powers. Okay, I still want to get to the variable by itself. So I'm going to start by adding 6. So 3x to the 4 thirds equals 6. Then I want to divide by 3. So x to the 4 thirds equals 2. Now, to get rid of a fraction power, you need to use the reciprocal power. So the reciprocal of 4 thirds is 3/4. And we do that because then you would say, oh, my 3's cancel out, my 4's cancel out. But the key thing to remember is that this is a power. So make it an exponent. Please don't just take 2 times 3/4. It's not. It's an exponent. So take 2 raised to the 3/4. Now, how do you tell on these problems? How do I know if I need a plus or minus or not? What you're going to do is you're going to look at the denominator. And if the denominator is an even number, and when I say denominator, I mean of the reciprocal power, not the original, but of the reciprocal power. So if I look at my denominator here, that's 4. 4 is even, so I got to have me a plus or minus, and then that works out to be a decimal of 1.68. All right, last one. Subtract 11 over. So x squared plus 9x plus 45 raised to the 1/3 equals 3. Okay, reciprocal power, which would be 3 over 1. So x squared plus 9x plus 45 equals no plus or minus because the denominator is 1 and 1 is odd. 3 to the 3rd power is 27. Move everything to the same side so you can factor. So x squared plus 9x Move this over so that it becomes plus 18 equals 0. Factor. Multiplies for 18, that adds for 9. And that is 6 and 3. Solve each parentheses, so I come up with x equals -6 and x equals -3. Done.